In last week's video, we left off by making our bird fall to the ground over time by using C# to set the bird's distance from ground property, and then also using C# to convert that property, that integer, into a CSS string, and then passing that CSS string into the style attribute of the bird div. So we were able to make the bird fall to the ground without using any JavaScript, which is pretty cool. Let's go ahead and move on, and we're going to now start adding some obstacles to this game. So the first thing that I'm going to do is I'm going to come into the game container, and I'm going to add a new div with the class of pipe. And then let's also come into our CSS, and let's give that pipe some styling. So I'm just going to copy and paste this in. So we're going to set the width of the pipe to be 60 pixels, which happens to be the same width of the bird. We're going to give it a height of 300 pixels, and we're going to make the background color black so we can see it. So I'm just going to run this and make sure that we can actually see the pipe render on the screen, and here it is. So we now have our pipe game element in here. So now let's focus on making the pipe move from the right side of the screen to the left side of the screen over time, just like we did with the bird element. So we're going to add another model in our models folder called pipe model. And so first let's give it, we're gonna add a public integer called distance from left. We're going to make it a public get and a private set, and by default we're going to set this value to 500 pixels. This is the game container width, so this will cause the pipe to generate or to render right outside of the game container. The other property that we're going to add to our pipe model class is going to be the distance from the bottom of the game container. So we'll say public distance from bottom, private set. And what this is going to, what we're going to use this for is we do not want to have a fixed distance from bottom for a pipe. Because if we did that, then every pipe that generates will generate at the same height, and our bird will just have to navigate through a straight path between those pipes. We want the pipes to generate at different heights, so the bird has to kind of zigzag through the different pipes that generate. So what we're going to do is we're going to add this distance from bottom property in our pipe model class, and we're going to assign it a random number between 0 and 60. So we'll say, by default, we're going to give this a new random. We're going to say next to get a random number between, we'll say 0 and 60. So whenever we generate a new pipe, we're going to randomly set the distance from the bottom of the game container to be between 0 and 60 pixels. Okay. Now let's come back into our game container and let's talk about what we want to do here. So we could, in the same way that we did with the bird CSS string right here, just create another string called pipe CSS and use that to style this pipe element. But that is going to get really messy. It would get particularly messy once we have multiple pipes on our screen. So let's clean this up a bit, and the way that we're going to do that is we're going to use components to represent the different game elements. So we're going to give the bird its own component, and we're going to give the pipe its own component. So let's come in, and in our components folder, I'm going to add a new component. This one will be for the bird. Let's do this one first. So we'll come into the game container, and let's just take this div that represents the bird, and we're going to just paste it in to our component. And then let's also cut this bird CSS string out, and let's add this to our code block within the component. And now, so the bird component obviously does not have a reference to the game manager right now. So it does not know how to find the bird object or the distance from ground property. So we need to pass in a parameter to this component. So we're gonna say parameter, and the bird component doesn't need access to the entire game manager. Really, all it needs access to is the bird object. So we're going to pass in a bird model. We're going to call it model. And this CSS is now going to reference not game manager.bird, but just model. We'll say model.distance from ground. Okay, so now we have a bird component that represents our bird game element. We're going to pass in the bird model, which should have all the properties that tell us how to style this bird model or this bird element. And so now let's come into our game container, and instead of having this div, we're going to replace that with a bird component, and we're going to pass in the bird model from our game manager. So now our bird component will have this same object, the same instance of the bird model class as the game manager has. Okay, let's do the same thing with our pipe. So we're going to come into our components and we will add a pipe component. And let's grab this div, and just like when we passed in an instance of the bird model class, we're going to, in this one, pass in an instance of pipe model. So we'll say public pipe model pipe. I'm going to do this on the same line for no reason other than I just think it looks better. And, oh, you know what? We can't name this pipe because the component's named pipe. Let's name this model like we did with the bird component. And then we need to build our CSS string. So let's just say pipe CSS. And this now has two things in it. So first we're going to set the left to be the distance from left property in our pipe model. And then we will set the bottom to be the distance from bottom property in our pipe model. And then let's also reference that CSS string in our style attribute. Whoops. And then finally, let's come into the game container and replace the pipe div with the pipe component and pass in the pipe model from our game manager, which we have not added yet. So let's also do that. So the bird component will take the bird model from the game manager. The pipe component will take the pipe model from the game manager. Let's go into the game manager and let's add a pipe model to this. So underneath the bird model, let's add a pipe to our game. You might notice, whoops, I went back in after this, the initial video, and made all of my properties private set because I was inconsistent with that. And sometimes I made them private, sometimes I made them public. That's just a consequence of me filming and not being totally paying attention to what I'm doing. So anyway, okay, let's come into our constructor and also say new pipe model. And now we should have an instance of the pipe model in our game manager class. So let's run this and see what happens. Okay, so our pipe is now generating outside of our game container. And if we start to refresh, we'll notice that the pipe is now generating at different distances from the bottom of the screen because we use that random number between 0 and 60. So it's going to put a bottom buffer between the pipe and the bottom of 0 to 60 pixels. And also if we click on it, the bird will animate. Nothing happens to the pipe because we haven't written that yet, but this still works. Adding the pipe and moving the bird into its own component has not changed any of this logic that we already wrote. Okay, Now we want to animate our pipe model. So let's come into our pipe, and we're going to add a method here called move. And we need to decide how much we want the pipe to move by. So I'm actually going to add another property here called speed. And I'm just going to give this a default value of 2. And so then in the move method, we will say distance from the left is minus equal speed. So subtract speed from the distance from left and set that to the new distance from left amount. Okay, so now we have a way to make our pipe move. So let's now call this in the main loop. I'm going to put this right underneath where we make the bird fall and then raise this property changed event. We're going to do a similar thing where we say pipe.move, and then we're going to say we're going to raise the property changed event for the pipe. And this is not what we're going to keep, so, but I just want to use this to explain what's going on. So we're going to say, make the bird fall, alert the UI that the bird property has changed, and then make the pipe fall and alert the UI that the pipe property has changed. We're going to run this, and you'll see that everything works fine. But let's take a closer look at what we're actually doing here. So we have our game manager here on our left and the game container on the right. Let's just walk through the steps of this while loop inside of our main loop. So first we call bird.fall, and we cause the bird's distance from ground property to change. And then we call property changed, and we say the thing that has changed is the bird. And then the game container is listening for this event to be raised. And so when that event is raised, we are calling state has changed. And what state has changed does within a component is it causes the component to re-render the pieces of itself that have changed. So Blazor is smart enough to recognize which pieces within the component actually need to be re-rendered. So when we call this property changed event, the game container is looking to see what needs to be re-rendered, and it's saying, hey, I noticed that the bird object has changed because its distance from ground property is now different. So I'm going to go ahead and just re-render this component, and I'm going to leave everything else alone. Then we call pipe.move, and we cause the pipe's distance from left property to be changed. And we invoke property changed again, and this time we pass in that the pipe object has changed. And again, that calls state has changed in the game container. The game container checks to see, has anything changed? And it says, okay, yeah, the pipe object has changed. Its distance from left property has changed. So let me re-render just this pipe component in here. And then this loop happens over and over again. But what I want to point out here is that I'm going to comment out this property changed event underneath pipe, and I'm going to run this again. And you'll notice that the pipe still moves when I run the game. The reason that this is happening, so this loop will execute once. The bird will fall, the UI will update, the pipe will move, the UI won't update yet. We're going to loop around, the bird's going to fall again, and then property changed is going to be called. And at this point, we have changes in our pipe from the last iteration of the while loop, and we have changes in our bird from this iteration of the while loop. So when property change is raised at this point, during the second and all subsequent iterations of this while loop, the game container, when it calls state has changed, it sees that both of these properties has changed. It isn't even looking at these events that we're passing through to it. The Blazor component is smart enough to recognize these changes by itself. So we don't need to tell it specifically what's changed. All we really need to do is tell it, hey, check to see if something's changed since the last time you rendered. So while this works, while we can invoke property changed after the bird falls and then immediately after the pipe moves, we're now raising these events twice in a 20 millisecond time frame, and it's being called immediately after the bird falls. So instead of doing it this way, it's going to be more efficient for us to just raise an event at the end of the while loop. So execute the while loop, do all of our game logic, and then after the while loop say, okay, game container, check to see if you need to re-render based on what I did in the while loop. And so essentially we are saying re-render the game container every 20 milliseconds by raising an event at the end. So let's do that. So I'm gonna just get rid of these property changed events altogether. And I'm gonna make my own simpler event handler. Let's get rid of this now. And we're just gonna call this on main loop, or we'll just say main loop completed. We don't need to implement this interface anymore. Whoops, I did not mean to do that. I meant to remove the usings. Okay, and so we have this new event handler here, and at the end of our main loop, we're just going to invoke main loop completed. So instead of keeping track of what has changed, we're just gonna say, hey, stuff has changed and I know you're smart enough to figure it out. So we're just gonna pass in empty event args.empty because we don't need to supply any information here. We just need an event to raise. And then in game container, instead of listening for property change, we are going to listen for main loop completed. So now, instead of re-rendering the game container every time we call bird.fall and then again every time we call pipe.move, we're just going to re-render it every 20 milliseconds and keep it simple. So if we run this now, and great, so both of these objects are animating as expected, and we're not calling property change. Instead, we're just raising our own event here just to say, hey, this loop has completed. Check if you need to update any of your stuff. Okay. So now we have two animated objects within our game container. Let's now add the ability to make our bird jump when we hit a key on the spacebar. The way that we're going to do that is we're going to do that using another event handler on our main game container div. And we're going to say on key up, we're going to listen for a key to be released on the keyboard. And we will call handle key up, which we will write in a second. But in order to listen for these key events, this div needs to be focusable. So by default, you cannot focus on a div. So to fix that, we're going to add this tab index attribute and say tab index equals 0. And this will allow us to focus on our game container so that we can listen for these keyboard events. So let's come down here and let's write our handle key up method. And this takes keyboard event args. So let's pass that in. And specifically, we want to listen to see if the spacebar key has been pressed. So we're going to say if e.key is equal to the spacebar, then we're going to make our bird jump. And for now, I'm going to directly access the jump method that we're going to write in a second within our bird model class, but we might refactor this, or we will refactor this in a moment. So let's go into our bird model. And let's add another method in here called jump. And we need to increase the distance from the ground now. And by how much? Let's make a new property in here called jump strength. And let's set this to 50. And that's just, you can play around with this. That's just from playing around with this / this is what the original creator used. So I'm just using that. So we're going to say increase by jump strength. Okay. So now from our game container, we're listening for a key up event, and we're going to make the bird jump if the key was the spacebar. So let's check and see if this is working. So when I start my game, I can make the bird jump with the spacebar. I can't jump with any other key, but there's going to be two things that we want to look out for. So first of all, I can make my bird jump completely off of the screen, which is probably not what we want to do. But also, once my bird reaches the ground, I'm still able to jump, because this jump method is not part of that main loop that we've stopped executing. So I'm still able to jump after the bird has touched the ground. So let's add in some checks here. So first of all, let's make it so that we can only make the bird jump if the game is running. So instead of adding that logic in here, let's just add a method in our game manager called jump. So I'm going to get rid of this. We're just going to call game manager.jump from the UI, and we'll come in here and we will say jump, and then we will check if the game is running, and if the game is running, we will then call bird.jump. So now we have this layer of logic here within our game manager to say, hey, if I'm running, then make the bird jump. So let's just check that out and make sure that works. So game is over, and now I can't jump. Okay. And then when checking if the bird is too high to jump, let's add that logic within our bird model class, since that's specific to our bird object. So in our jump method, let's add a check here to say if distance from ground is less than or equal to, let's say 530. And this is just from me, again, playing around with this. Then we will allow the bird to jump. If it's greater than this amount, then we can't jump. So let's test this out. And you'll see that the bird can still jump a little bit off the screen, but not completely off the screen. So this is just my choice in making it 530, but you can play around with this and make it what you want. Later, we'll add borders around the game so that it hides the elements that are peeking outside of the game container, so it won't look as awkward. So that's what I've decided to do for that. Okay. So now we have a way to make our bird model jump, our bird jump. We also have a animated pipe in our game. So let's go back and see what we've got. So we've got our bird. It can jump and it can fall to the ground, and that's basically all the bird's gonna do. So basically, in terms of controlling the bird, that's finished. What we need to do with our pipes is first we need to create multiple pipes. So in the game, there's going to be multiple obstacles on the screen at the same time. So we're going to be adding a collection of pipes. Let's start by changing the pipe model to a list. So we're going to say now this is a list of pipe models. We're going to call it pipes. In here, we're going to say new list of pipe models. And then within our while loop, instead of calling pipe.move, we're going to now loop through each pipe in the list of pipes and call pipe.move for each pipe. And then finally, in our game container, instead of just having one pipe component here, we are going to also have a for each loop within our Razor page or Razor component. So we're going to say for each pipe in game manager.pipes, we're going to add a pipe component, and we're going to pass in this pipe. Okay, so we could run our game now, but it's not going to be very interesting because our list is empty and we don't have any way, we haven't written any code to add pipes to the list. So this is just going to be just our bird right now. So let's change that. And let's do a little bit of refactoring here just because our main loop is going to get really messy if we don't. So first of all, I'm going to come down here. I'm going to make a method called move objects, and objects plural. And let's put this stuff where we make our bird and our pipes move within our move objects method, and then call that from the main loop. So the first thing we do in the main loop is move the objects. The second thing that we do is check for collisions. So let's add a method here called check for collisions. We'll add this check here. Later we'll also add a check to see if the pipe has collided with the bird. And we'll say check for collisions. And then we will keep this. So we'll say after we've done everything in our main loop, call or raise the main loop completed event, and then wait 20 milliseconds rather. Okay, the next thing that we want to do is we want to see if we need to add new pipes to our list. So I'm going to call this method manage pipes, and we'll come down here and write this. And the first thing that we're going to do is we're going to say if the list of pipes does not have any objects, then we're going to add a pipe to the list. Also, or if the last pipe in the list, which is the rightmost pipe in the list, if that pipe's distance from left is less than or equal to, and we're just gonna say 250 for now, then we're going to add a new pipe model to our pipes list. Okay, so within our while loop now, we're gonna say move objects, check for collisions, and then check to see if we need to add more pipes to our list. So let's see what this does. So you see that there's no pipes here because we're starting with an empty list. But if we now run the game, we'll see a pipe has generated, another pipe generates, another pipe generates. So cool, we're getting pipes generating over time, and you'll notice that the distances are all different, which is what we want. So one other thing that we probably want to be careful of is that as this game is running right now, we are just adding more and more pipes to our pipe list. And if we were playing for a long time, this pipe list would become huge. So let's also in our manage pipes method, check to see if we need to remove any pipes, and we will remove a pipe if it is off screen. So let's now make a check, and we're just gonna check to see if the leftmost pipe, so pipes.first, is off the screen. So I'm gonna add a method in here called isOffScreen. We'll write that in a second. Then we will remove that pipe. So if the first pipe in the list is off the screen, then remove the first pipe in the list. Let's write this in our pipe model class. So we will say public void is off screen. Actually, this is a bool. Return a boolean. And this will just check to see if the distance from the left is less than or equal to -60. -60 is the width of the pipe. So if the entire pipe is outside of the left of our game container, then we will return true that it is off screen. Now, this is reminding me now that so we just created this is off screen method within our pipes model class. Someone pointed out last time that we probably should do a similar thing in our bird model, where we're instead of saying bird.distance from ground less than or equal to 0 within our game manager, this should probably be a method within our bird model class we're calling room game manager, which is true. So we should do that to be consistent. So I'm going to come into our bird model class and write a similar method. We'll just say bool is on ground, and this will return whether the distance from the ground is less than or equal to 0. And instead of doing this logic here, let's just call is on ground to make our code easier to read and just all around cleaner. Okay, so now if we press play, we should see on the side of the screen here that when the pipe, and that's a bug actually that we should fix. So when I clicked start, when I restarted the game, the pipes are not resetting. So we need to fix that. But let's just see that you can see it disappear right when the pipe leaves the outside of the game container. So that's what we want. Let's fix that bug where where the pipes are not resetting. So within our start game loop, we're just going to say pipes is equal to a new list of pipe models. So we're not keeping the old list when we start a new game. Let's make sure that that works. So we'll start our game, let our bird go to the ground, and then let's restart it, and we can see that a new list of pipe objects are generating. So awesome. Okay, this is going to be the end of this video. In the next video, we'll deal with the collisions between the bird and the pipe objects, and we will add the top pipe, and then we will wrap it all up by replacing these blocky looking elements with actual background images so it looks like a real game. So if you're interested in seeing that, make sure to subscribe, and I will be back next Sunday with a part 3. Thanks for watching, and see you next time.